Thanks for that very generous introduction. And good afternoon. So I'm really excited to be here speaking at Monitorama EU. I'd like to talk today about the idea of fewer, better systems. So very briefly, my name is McGranaghan. I work at Heroku. Heroku is a cloud application platform, so a lot of distributed systems work and a lot of operations. And a huge amount of our work is operations, so that informs a lot of what I'll talk about today. And with this idea of fewer, better systems, I'd like to start with two stories. And these stories are going to be, they're going to lead to themes that we'll talk about throughout the talk. So the first one of these stories is about Unix. And in particular, the idea that everything is a file. So this is a common idea in Unix, right? And the idea is all of our objects in Unix, like our database files and our binaries and our configuration, and even devices like sockets and so on, can be accessed with files. And the point with everything is a file isn't that everything is literally a physical file. It's not so much an observation as it is a strategy about how we'll solve problems in that space. And so the point is you're projecting a bunch of different problems onto a single shape. In this case, the shape is a file. And then as a corollary, you get solutions against that shape, and you avoid the m by n problem. If you create a new solution against files, you solve a bunch of problems. And if you have a new problem, you get a bunch of solutions for free, as long as they go through that file interface. So the first theme is everything is a something for different values of something. I think that's an interesting idea that we can apply more to monitoring, and we'll see how. So the second story is about failover. Who has had a master follower set up in production that was meant to fail over and didn't at the right time? Yeah, let's see those hands. So how this story is supposed to go is you have a primary and a secondary, and they're exactly the same, and you take equally good care of both of them, and the caches are just as warm, and you have just as good a monitoring around both of them, and so on. Of course, in practice, because you're not practicing on the secondary in the same way that you are on the primary, the secondary tends to kind of fade away, and eventually it might go a little bit sideways, which is great until it isn't when you lose the primary, and now you're in this position of, okay, where is the secondary? How do I fail over? How do I fail back? I haven't tried this in a year. I hope it goes okay. It doesn't go okay, of course, etc. And Ben Black had this great tweet, which I think sums up perfectly when he said, basically, there's stuff that you use all the time and stuff that doesn't work. So that's the second theme of this talk about having fewer, better systems. It's the idea that the best systems are used constantly, in the sense of the systems that are on the canonical path, the only path, the hot path. We practice with them a lot, and they're not special cases, especially special cases that you only invoke when things are going badly. So fewer, better systems through the idea of everything is a something, and best systems are used constantly. I'd like to look at, as a motivation for that, some specific examples in monitoring and operations. These are 4 bread and butter areas that I think would benefit from this sort of thinking. So the first is logs and events. Logs, events, and their cousin metrics are substantially the only data we have about what happened in the past in our system. So they're critical. It's how we do forensics. It's how we understand what went wrong. It's how we understand bugs that we didn't understand before. So got to do a good job with these. The state of the art is maybe not awesome on logs and events. So at a very high level, we have logs, which are classically streams of unstructured information, lines of text that you're spitting out to syslog or whatever. And then you have events, which are streams of structured information. So you can see where this might be going. But it's actually even more troublesome than n equals 2. The reality is it's kind of n equals infinity with a bunch of special snowflakes everywhere. So here are some common log lines that you might see in a production system. You have the Apache common log format. Another example here is Rails database logs, and there's also a Rails controller log. And what you'll see is these logs are great in the sense that they have a bunch of important data about your system that you might want to see in real time or see historically or graph or so on. But we're inventing ways to encode this data in text each time. Like each one of these log types is basically our own mini serialization format that we've invented for this particular case in our systems. And these are proliferating all over the place. there's even a little game you can play, which is like, how many different ways can we encode data in a log line? You got like the brackets and the quotes and the pipe and the curly braces and the parens, and it's kind of a mess. And then you run out and you have to go like positional arguments, like in Apache log. It's no fun. Meanwhile, as a direct corollary of all this, we have all kinds of different special Snowflake log parsers and analyzers. So, there's Apache log parser analyzers, there's Postgres log parser analyzers, there's one for Redis, there's one for Heroku, there's one for Rails application logs. And you see these announcements on, GitHub all the time, like new special case log parser for Apache in real time. It's like, great, now you have, your special Snowflake is even more special. So not doing very well in this space with everything is a something. There's no something. Everything is a Snowflake. But I think the open source community and the monitoring community and the operations community are moving in the direction of a better solution here. They're starting to converge, I think, on this related idea, which is events. So events solve the same problem as logs. They capture information about something that happened in a point in time, but they do it in a uniform way. So it's just data that you encode in a normalized way about what happened in your system. So this event, for example, could represent the same occurrence as this Apache log line, the same data, but it's encoded in a uniform way. So events are data encoded as data uniformly, and as a result of that, we can analyze events with general tools. This is something we do a lot of at Heroku in our production systems, trying to converge all of our log-like things to basically key value pairs, which we can then analyze with normalized tools across our whole stack. But you can also see it, like I said, in open source. So one really good example of this is FluentD. And FluentD is, well, it's what it says on the box. You log everything in JSON. And you might say something about JSON versus other formats and text and so on, but the idea of logging events as data is spot on, I think. So this is what FluentD looks like in practice. You have a time, a tag, which is the type of event, and then just data, which you submit to the FluentD collector. And FluentD has that same bow tie shape that you see with files in Linux and Unix. Everything kind of comes into a centralized format, and then from there you can write general purpose tools that work against all your data in production. Same type of shape. So, kind of high-level conclusions about logs and data. Something happened at some time, call it an event, that's what it is. And events, ideally, are represented as data and not strings that you're passing around. And if we can do that, we can get to the point of general purpose event processing applicable to all the information in our stack. So, idea there was everything is an event. Second topic here is related. This is the one of alert criteria and metrics. We've heard a lot about metrics and alerts, and I think for folks in this room, it's more obvious at this point, but this is an idea that I still think is working its way through the community, and it's worth emphasizing. So, one way to do alerting and metrics is you have an alerting stack, which is every 10 seconds, go out to this thing and measure it, and if for more than 5 times in a row it's out of some bounds, alert someone. And then separately, you have a metric stack, which is every 10 seconds, go out and measure this thing and put it in a store. So graphically, it might look like this, 2 separate worlds. You have the steady state world of we're doing this constantly, putting this in a long-term store, building nice time series, and so on. And then as a special case, you sort of invoke this alert path where the separate system over here found this value that's bad, and now we're going to alert on it. And the discontinuity here is in time. So, and it comes at the worst point, right? You have an alert that's coming to you from a system. It's like, value request per second was too high over the last minute. It's now X. Fix it. And in order to do that, you need to come and figure out how it relates to the steady state of your systems over time. So the solution that, again, I think we're seeing a lot of now is make this all one stack for all of your alerting needs. And in particular, have a measuring system that goes out every 10 seconds and say, what's the value of this? Puts it in a store, and then alerting goes off that canonical data. So you only have one path for data that you're alerting against, you're monitoring against, you're operating against, you're visualizing, and so on. So an example from production at Heroku, where we use this technique. I mean, we use it all over the place, but this is a specific case. We have a system that we want to monitor the availability of, and if it ever goes below some red line, which in this case is 95%, we want to page someone. But when we get this page, when this page hits, it's basically coming with, for free, a graph of this context. And we know that resolution corresponds to fixing that exact line. So instead of getting a single vertical line corresponding to a bad event, you have the full context there. And then as a bonus, you can do great historical analysis. So instead of going back in time and counting the number of alerts I got on this thing, which you might also want to do, you can go back and actually integrate the area under this curve to get the availability of the system you were monitoring. So at a high level, conclusions here are every alert has a time series. I think this is an interesting idea even for things that are very binary, like liveness alerts, so you can see over time what that step function looks like. And alerts come from your canonical time series in the metric stack, and for free you get your alert source data stored for all time. And I think this speaks to the idea of the best systems are used constantly. There's only one path for metrics in production, and it's shared by your visualization, alerting, and historical analysis, and so on. All right, so as we go down the stack here, they're going to get increasingly abstract. But this is an interesting one about integration testing and quality of service monitoring. So this idea was planted in my head by an essay by Steve Yigi called Steve Yigi's Google Platform Rant, which you haven't read. You have to go read it. It's amazing. It's a great essay about systems design and how people interact with systems and so on. But one of the seeds he planted in that essay was that consider monitoring and QA, automated monitoring and automated QA. As you get into a bigger and bigger SOA, those things become very related. In particular, you can only monitor classically a single component in isolation, but QA is about monitoring the entire call graph. So once you start programmatically monitoring the entire call graph, you're basically doing automated QA in a way. So it's that idea that monitoring and QA and integration testing are all sort of related as you kind of get scale equals infinity. So I'd like to look in particular at integration testing and quality of service monitoring. So integration testing classically would be like, okay, I wrote some software. Before I put it in production, I want to make sure it works. So I'll say, run some tests. Is this good enough for production? Great. Throw it over the wall to production. And then in production, we want to make sure it continues to work well, so you do quality of service monitoring there. Is it behaving as we want to, and so on. Well, if you actually look at what happens, these are quite similar. So integration testing would be like, run through some common user flows, assert that there are no errors happening, make sure the performance is good. And where this is going, quality of service monitoring looks suspiciously similar. Users are running through flows. We want to make sure that there are no errors, ensure performance is good. So maybe there's a way in which we can leverage this similarity. But the status quo looks something like this. You have an integration harness that you put around staging or some other integration environment. And it's sort of an isolated thing that only handles staging. It's a full vertical stack. It does load simulation. It assesses the results. And when you're done, you kind of turn it off and you just go to production. And then you have a separate stack that you're separately maintaining over here in production. The idea of promoting through different environments makes perfect sense, but having wildly different setups, I don't think does. And I think an alternate setup looks something like this. You have a quality of service monitoring setup that you can either set up against or point to different environments. So you take your monitoring stack, you set it up against production, you take your monitoring stack and you set it up also against your live staging environment, and you run that continuously. It doesn't page people, but it's producing graphs and everything. And then in that staging environment, you're continuously generating load that simulates production. So you're creating basically a hot staging environment all the time, 24/7. And then as the size of your system grows and you have more and more team members contributing against that staging environment, integrating in there, whenever they come in, it's a hot environment that they need to integrate against. They need to go through a normal deploy process that when users are using it, and you need to deal with hot compatibility and so on. And then basically the test is, do I set off any quality of service monitors in that integration environment? And then as bonus points, you can take that load gen system and point it at a slice of production even. You can say, like, these are my canary requests that I'm putting through my production environment, and I want to check on the bottom with my quality of service monitoring system, are those working as I expect? So please don't tweet that Mark said not to do integration testing. That's not the point. The point is that integration testing and quality of service monitoring might be quite similar, and it's worth thinking about that similarity and taking advantage of it. In particular, by investing in load generation and replay that you can use anywhere, and investing in quality of service monitoring that you can use anywhere, and making those production and staging environments, both in terms of the architecture and how they're operated and monitored and their liveness, as similar as possible. Again, this is the idea of the best systems are used constantly. We've had so many cases at Heroku where if we had a static staging environment where we just ran integration tests once, we would never have caught this stuff. So just make it live, run all the time. All right, errors and results. Now you're probably like, Mark's jumping the shark. Errors and results, those are not the same. Yes, well, it is a little bit tricky. But let's talk through this a little bit. So errors are something happened and it was bad, and the result of something happening and it was okay. Okay. Let's start with something really concrete, like an actual Ruby code snippet about error handling. And you have like a begin, you call a function, and there's some exceptional case which you rescue from and handle the error. Well, I think we're already getting off to a bad start. And we're looking very locally, but I think this is symptomatic of how we look at systems in general. We have this thing called an exception, and we define exceptions in terms of how often they happen. Like, they're unusual, they're not typical, they're rare, they're unexpected, which makes sense locally and for small systems, but we're no longer writing as many of those. And in particular, exceptions are only really exceptional at small scale. Like 1 in a billion happens all the time at Heroku. So we can't treat exceptions in terms of how rarely they do or don't occur. Instead, we need to treat them by their shape and treat them as basically a normal case. And let's see how this applies to like open source. So it's harder to see this at the systems level because it's so abstract, but one open source project that I do think gets this right is Go, actually. So Go has a very interesting error handle philosophy, which is errors are as close to results as possible, but no more. So they're not exactly the same thing, right? Because they have different shapes, but they're otherwise handled exactly the same. They both come back as return values from the function. They're both applicable to all of the, you can apply all the regular programming language constructs against them. They don't have special cases and so on. So what would that look like at a systems level? So we looked at this example, which is all about a local piece of code, which I think is symptomatic of what's happening, but the more interesting story is with scale and with scope. And in particular, there's really no notion of locality in errors in general for distributed systems. So for example, errors in distributed systems are not local to some particular space or node. They could be service level errors, like 99.9% of my requests across all the node are causing errors. So if you have a notion of errors and error handling that's local to a node, you're going to have a bad time. Likewise, errors aren't even local in time. You can define them post hoc and come back and say, this type of request path was doing badly, I need to go back and understand why. So here's how we connect back to results then. We look at an error and realize it's not even, there's actually not much, not that we can differentiate about an error at development time. It's basically just a result, and we need to treat that result symmetrically as much as possible to how we treat other results in our distributed system. And in particular, we need to go in and log that event, which may or may not look like an error now, with all of its data, and generate a notion of errors separately at the systems level. So high-level thoughts here are treat exceptions and results as symmetrically as possible, to the greatest extent possible, and expect not to just define errors at development time, but also analysis time and runtime. So everything is a result. Basically you're making calls in your distributed system, and you're going to get back data, log that data out, and analyze it later. So 4 specific areas of monitoring and operation, which I think illustrate these ideas. But the more important thing to take away, I think, is the state of mind about this as it applies to how we monitor and operate systems. You're going to hear a lot today about great new software that you could add to your infrastructure and great new processes that you could add. So my challenge to you is, how can we take things away? How can we use this new technology and new ideas to do less in our systems and do them better? So think about everything is a something in my system, and I'm using the system constantly versus treating it as a special case. I hope that leads to fewer better systems for you. Thanks.
We have a few minutes. Does anybody have any questions for Mark?
Joe.
You said like load generation briefly. What do you guys think about production traffic?
Yeah, I've heard that used successfully. Oh, thank you. The question was, you mentioned replaying production traffic. What do you think about teeing traffic? Basically duplicating traffic against a separate environment. I think it's a really interesting idea. We don't do that in particular at Heroku, and that becomes more and more challenging as it becomes more and more write-heavy, and you also don't control the destination of the writes. It's like at Heroku, people have databases that are run by third-party providers and so on. So it's an interesting idea, but however you can generate load is great. All right, thanks.